Have you ever wondered what really happens after you toss a plastic bottle into the recycling bin? The reality is a lot more complicated than you'd think, but a powerful new technology is starting to change the entire game. Today, we're going to break down how artificial intelligence is giving our global recycling system a much-needed, high-tech upgrade. To really get why this is so critical, let's just start with a number. By 2025, we are on track to generate 2.2 billion tons of waste every single year. That's a weight so enormous, it puts this incredible, almost unimaginable pressure on our entire planet and all its resources.
And, the research backs this up. The problem is only accelerating. We are creating more waste right now than at any other point in human history. So this isn't an issue we can just ignore. It absolutely demands some powerful, innovative solutions.
So let's break that down, because the journey from your recycling bin all the way back into a new product, well, it's absolutely filled with challenges.
And a huge one is purity. Just think about all the different types of plastic. You've got PET bottles, HDPE milk jugs, polypropylene containers, the list goes on. For recycling to actually be effective and, economically viable, these materials have to be separated cleanly. When different plastics get all mixed up or they get contaminated with other junk, the value of that recycled material just plummets. And honestly, a lot of the time, it just ends up in a landfill anyway.
So how in the world do you solve a problem of sorting through literal mountains of complex waste? Well, you give the system a bigger brain. And that's exactly where machine learning comes in. It's acting like a powerful new intelligence for our entire recycling infrastructure.
So what is machine learning, really? Okay, think of it this way. It's a type of AI that lets a computer learn from data and spot patterns, all without a human programmer having to tell it exactly what to do for every single scenario. It learns from experience, kind of like we do.
In this learning process, it's a lot like studying for a big exam. First up is training, where the AI just crams, looking at a massive data set of images. Then you've got cross-validation, which is like the practice quizzes, making sure the AI actually understands the concepts and isn't just memorizing answers. And finally, there's testing, the final exam on brand new data to prove it's ready for the real world.
All right, so once the AI has graduated, it's ready for the job. Okay, let's dive into this. We're going to see how all that learning gets applied to that crucial first step, sorting the waste.
So how does an AI actually see a conveyor belt piled with trash and know what's what? The process is actually a lot like our own vision, but it's been supercharged with just massive amounts of data and hyper-precise sensors.
Now, what's really interesting here is that we can kind of peek inside the AI's brain. Let's forget the jargon for a second and just think of it as a four-step inspection line. An image of a plastic bottle comes in. Step one spots the basic features, like edges and colors. The next couple of steps simplify that info, zeroing in on what's important. And then that final step puts all the clues together to make the call. Yep, that's a PT bottle. It's this super rapid, layered analysis that makes it so powerful.
And the results? They're staggering. Look at this chart. We don't need to get into the different model names. The key takeaway is their accuracy. We're talking 96, even over 98%. That's a level of precision that humans sorting by hand would find nearly impossible to keep up hour after hour.
And all that precision, it isn't just for some cool science project. It has a massive real-world impact. Higher purity in recycled materials means more of what you put in your recycling bin actually gets turned into new products. It helps close that circular economy loop and gives our waste a true second life.
Okay, let's move on, because AI's role in recycling doesn't just stop at the sorting line, not by a long shot. It's helping to revolutionize the entire process, from start to finish.
So, once sorted, plastic can take a few different paths. The most common is mechanical recycling. That's basically just melting it down and reshaping it. But the more advanced methods are where things get really interesting. These are the chemical and biological routes that can break plastics all the way down to their original, pristine building blocks. This biological approach, in particular, is pretty amazing. It uses nature's own tools, specifically enzymes, to deconstruct plastics. This is an incredibly exciting new frontier where AI and biology are actually teaming up to solve one of our toughest waste problems.
And this just brilliantly illustrates that magic in action. Think of an enzyme as a tiny biological robot. It finds a plastic chain, latches on, and then precisely snips it apart into its original molecules. Those can then be used to make perfect, brand new plastic. So where does AI fit in? Well, scientists are using AI to discover and even design super efficient enzymes that can do this job faster and on more types of plastic than we ever thought was possible.
Now, as promising as all of this sounds, we're not quite living in a perfect recycling utopia, at least not yet. There are still some pretty significant hurdles to overcome before this technology can be rolled out on a global scale.
So what's holding this back from being everywhere? Well, the hurdles are pretty big. These AI systems need a ton of data to learn, and the robotic hardware can be really expensive to install. Plus, let's be honest, real-world trash is messy and unpredictable, and getting all the right experts, from computer scientists to material scientists, to work together is a huge challenge in itself.
But despite those challenges, the potential is it's undeniable. We're seeing AI deliver unprecedented precision in sorting. We're seeing it optimize complex chemical processes and even help design new biological tools to deconstruct waste. It really raises a fascinating question for the future. As this technology continues to evolve, could artificial intelligence be the key that finally unlocks a truly sustainable circular economy? Thanks for tuning in.